Hello everybody, it is Mike Levin on Friday, March 19th, 2021. And a question was posted to my videos, which I was kind enough to answer in text, and it has since disappeared. I think people sometimes delete their questions once they realize there's a fairly simple answer, but his question inspired me. He's like, where to begin with Python? So many words. So I'm at a pretty advanced place in my videos, and I'm going to back up a bit and speak to the noobs who may just be joining in now. Where to begin in Python to win? It's easy, but you've got to wonder. Past 3 data types, I've got a few gripes. Namely, you got to know dunder. Dunder, I say, is just a display. Underscores on either side of an internal, though it looks infernal, conventional names won't collide. So all that dunder stuff you see is Guido van Rossum, the creator of Python, just making sure that he's using variable names in environments that won't collide with other local variable names in that same environment, sometimes main or global, these namespaces that are either there automatically or that get created by your functions and methods. So even that comes off as blah, blah, blah to a lot of people who are really just getting started with Python. So in speaking to you, step one is always get Jupyter Notebook installed. These days through Anaconda. There's nothing wrong with a little Anaconda in your life right now, but in the future, look to be able to just pip install Jupyter and have it as a running server, the whole job done. What you won't get is a lot of pre-installed components that are always considered essential for the data scientist types, which is driving the uptake of Anaconda, which is making more people discover Jupyter Notebooks, which is making more people move on to the Jupyter Lab environment, such as me, where a lot of interesting stuff is occurring. So because of the Python packaging index's adoption of binaries on an install, aka wheels, things like NumPy installs, which used to require the Linux compile toolchain, GCC, and common tools and such, in order to build locally, now suddenly become easy to install. And so there is a bright, interesting time of notebook-centric ecosystems upon us. It's a great time to join in. You're there when this stuff, the Jupyter Notebook stuff, is becoming really popular. And as much as people love VS Code these days, which it really is a decent text editor, this notebook environment is really where the innovation is occurring. All the libraries that are being used for the IntelliSense lookups and for color coding the syntax of the language, this is all being lifted from this project. The idea of a REPL environment that uses wonderful code blocks, and you can make those code blocks really big so that these things can gradually be upgraded into real Python packages instead of the .ipynb files. They can also have this parallel existence as .py files, and you have all these other advantages of the language. Now again, it's all coming off as blah blah blah, but what you should really take away from this is that when you get started with a fresh new notebook, whoops, I'm adding cells. See, already interface ambiguity, the fact that I'm at this a while and I hit that, so I hit Control B to bring this thing back, and then I hit that, which gives me the much more familiar launcher, but it is that same plus looking things. There's a few OS overlap, talk about colliding things in namespace, right? All these similar concepts visually and word-wise. Okay, so I create a new Python notebook, untitled1.ipynb. That'll become very familiar to people really just getting started, because that's the real starting point. You install Jupyter Lab, Jupyter Notebook, Jupyter Lab through Anaconda, and then from your start menu, you'll be able, and I went full screen mode, so it's really focused here. You can strip away most of what's distracting. That's why I like to do this Control B. You just got to learn to find this stuff on the menus or use the keyboard shortcuts, a lot of muscle memory things. And so that's actually an important point here. I'm looking for the same timelessness of tools in notebooks, Jupyter. These things are really quite inseparable. The industry has adopted the term notebooks in all sorts of things, you know, Azure notebooks, Google Colab, but really at the heart, this is all inspired by a free and open source project. Right? This is in the FOSS world, Jupyter. And the organization that is now called Anaconda has gone a bit more commercial with their licenses. And that's fair, and we adapt. It just means that you'll install more of your components with pip install. And I won't even get to that yet, because if you're really getting started, what you need to know is those 3 data types I alluded to in the poem. Once you decide to do this, and you've got Anaconda installed, and you've got a new untitled.ipynb, and you're wondering why you're here instead of VS Code, just remember you're not beholden to a vendor. This is the free and open source version of all that VS Code stuff, but you're dealing with .ipynb files, which are notebooks. That's what a notebook is, an IPython notebook. You're dealing with them instead of the .py files directly, which is the pure code behind this that you're executing with all the metadata and mixing in of markdown code of the Jupyter notebook environment stripped out. So we're in a meta programming environment. It's a REPL environment. So where do you begin? You begin with 3 words. These words are list. Okay, see? The interpreter knows you're doing something that makes sense to it. There wasn't an error. The next thing is a tuple. Okay, and you can see the color coding kick in, and it tells you you're typing the right thing because it recognizes the keyword. And the last thing is a dict. Okay, and I will throw in an honorary 4th one, just so that you know. It's like the plasma. It's the, you know, there's 3 forms of matter plus plasma. Sets are always around. Sets are actually a part of dict, the keys of dict. But before I confuse you with all of that, I think I'm going to get rid of set now that I let you know they exist. We really want to point out the fact that you can always inspect the type of a thing. Okay, the type of a list is a type. So it gets a little circular and self-referential, but let's type list with an open close parenthesis after it, and you can see that, oh, I am calling that type. When you call that type, it is now suddenly an instance of that type, which happens to be list. So I think I'll keep both of these versions up here and re-execute it so it looks correct. And in this way, you can start to inspect things. Once you understand something's type, and once you understand that there's more to a word than just the non-parenthesized version of it, you'll see that adding an open close parenthesis here makes something happen to the word, right? So what if we just did list out here with open close, right? You get the square brackets, which is the visual representation that you get to use for a list. So in Python, it turns out that if you use these square brackets and you put anything separated by commas, the spaces are arbitrary, but they're good form, and you run it, you will actually have a list. See? And you can start to do things with this list like loops. Now, this is where habits generally go bad. I'm going to show you First the bad habit, then I'm going to show you the good right away, and you can forget the bad even though you learned it first. Since this is a list, I ought to use the copy-paste function of Jupyter since it's there. You can say for arbitrary, and I'm typing it out so you can see, arbitrary word chosen at random in, right? So I just want to really hit home the arbitrariness of that word, because people think it has meaning. You use an example keyword in your variable name. It's not even a variable, it's a reference name in Python, but people think it has special meaning. So I really want to make the point that this is no different than the eternal foo, right? Hey, look, it is different. 333. So there's going to be a very interesting thing, I suppose, to demonstrate here, because now that list contains 3 threes in it, even though it's for foo. And oh yeah, there, scope, of course. It is completely different, and there I'll keep my mistakes intact. I keep my mistakes intact to show you common programming errors, right? So, changing variable names around, especially in one of these REPL environments where it doesn't forget a value. These things are always in memory. So since we used foo, even though it was for an iterator of a loop, the value of foo is still there. It's a way to check, say, the last number that got used as things went through a loop, because this is still running in memory. Just as if you ran something from the command line as a Python space filename.py, that ends. After that's run and it got to the end of the program, the interpreter, really much more than the interpreter these days, but the python.exe, if you will, exits. And that is not the case here in these REPL environments. Every variable you use is still around to be looked at again. And in this way, you can keep on programming, and this encourages a style of programming that gives notebooks sort of a bad name, but you can think of it as just a calculator, right? So much of Python is revealed in just what I've done right here. But I told you there was a bad way and a good way, and then I got distracted by my stupid mistake. Here is that list again. And I put it here, okay? Now to step through that, the last time I used an arbitrary file name, word, variable, whatever you want to call it, reference here and here. Now say I wanted to do that even more efficiently on one line. I could say foo for foo in. Foo for foo in. No, I can't. That's a mistake I keep making in these videos and demonstrating list comprehensions on the inside. I'll keep that intact too. What I meant to say is you can put another set of square brackets around it. And if you were to execute that, that is in fact a list inside of a list, showing that these shapes can be nested inside each other. That nestedness is an important point for you to tuck away in your brain. The API of list comprehensions is indeed a bit strange. You create a nested list, and in the space you create by nesting lists, you can put I want to say file handle, because that's how I've learned to think of these things, but it is a handle to an internal. And I'm using foo because I used it up here, but the pattern you will continuously hear me invoking for list comprehension is x for x in, right? So now you can do things like, say you wanted to turn that into a string. The new notation for strings is wonderful. If you put a single or double quotes around something, and then inside of that you put the curly brackets, and then you put an F out here, that is a way of turning something into a string. But you get to put things inside that string such as that, which is how I made the names that I used in this other video I made. That's how I made function names. So you can see that's list comprehensions. But what if you wanted something simpler here? What if you were maintaining a list as a variable name? Well, this is part of lists, and now this is a mutable object. Now remember, this mutable object, this word that I'm using here, has no meaning other than some arbitrary, I pulled it out of the air, just like arbitrary word chosen at random, okay? And I can say that is equal to this list. And that equals sign is an assignment as opposed to an equality operator. So one of the key things you want to keep straight in your mind about Python and many languages that make this strange, very close in symbolic relationship between these fairly distant apart concepts of assigning or an assignment operator. And this is just a comment I'm making, so I'm going to change this to Markdown because I'm just talking here. So it's not code I can execute, right? I can make it a headline if I want by putting a thing there, and assignment operator. Sets values. Values. Using equals is actually strange. You need to know that. It's a strange thing to say this equals this, and you're saying you're assigning this value to this reference. Okay, so have I done it? I didn't run it. Now I've run it. So now I have this mutable object. Now I have this mutable object. And you can see when you run it in a code block, it shows its value. Now that's Jupyter Notebook doing that because I didn't ask for a print statement. Typically, if you were doing this, you would actually want to do that to see the object, and you see it with its string representation. Now don't let that fool you. Just because there is a string representation does not mean that it's something other than a string. It is completely something other than a string because you can append it to a list. This is why it's a mutable object. Mutable objects can be appended to. Okay? And now we can once again print, but the out of orderness of notebooks gets confusing, so I'll just copy paste that there. 1, 2, 3 mutable objects can be appended to. Tuples cannot. Dictionaries can have new values added, new key value pairs added, but this would be much, much too long of a video if I got into tuples and dictionaries, because each of these is all its own special thing. And of the three special words, the list, the tuple, and the dict, we have shown you a lot of things that you need to know about the general Python environment. Another interesting one that I thought of is these square brackets popped up and we started to use them right away, but it's very important to know that dict, no, it's the list we're using, list can be used the exact same way. So if you wanted 1, 2, 3 as a list, oh, yeah, parameters, okay, it's got to be fed in somehow. I'll give you a preview of the tuple. A list is a operator on data. Using square brackets to achieve the same thing is syntactic sugar that the clever creator of Python sprinkled in so you don't have to actually be using the list operator spelled out long all the time everywhere you use a list. It would just be such a pain. Plus a parenthesis as a grouping unit of objects you're feeding into it, because you need a syntax to be able to do it on raw data. I suppose you could use a variable name, but it's chicken and egg. You would have had to have defined it as a list somewhere, unless you went through an API like append to build a list every time, but no one wants to do that. They want to build it as strings and say, poof, it's a list. I hope some of this is making sense to you, ladies and gentlemen, because I pretty much have to wrap up and go. But that, I do believe, tells a lot of the story that needs to be told here. Syntactic sugar is at play. There's API magic going on, and Python can do API magic. You'll see in various places the meaning of the slash switch between divide and appending directories and files together under the pathlib API. Pandas does a bit of API creativity and getting rid of square brackets where you normally would have to use them in places in Python. And yeah, there's a lot of API creativity going on. So you're in an environment which is predominated by the use of lists, tuples, and dicts that have their representations in the following ways. I just invoke it. Square brackets for a list, parentheses for tuples, that gets pretty meta, and curly brackets for a dict. So even though I showed you mostly about the mutable data type list on this video, we will soon cover the immutable data type, the tuple, and the little key value dictionary, NoSQL, JSON, API friendly data type you can carry around anywhere you go, and give you a good foundation of Python. Those three things, good foundation of Python. There's your white space indent, there's your using of a print function, there's your string replacement and list comprehension, your basic loop is up here. And what more do you need to know about the language? There, you just learned Python. You're welcome. Thanks for joining me. Hope to see you again soon. And don't forget to subscribe.